Welcome, folks. Today, lesson 3.2, complex numbers. We're going to expand more on the solving quadratic equations that we've been doing up to this point. But before we do that, we need to talk about what complex numbers are. So up until this point, you've been working a lot with all of the real numbers. All of your answers have worked out nicely, and you've been in this world and living in this world of real numbers. Right? Integer values, fractions, decimals, square roots of numbers. But outside of the real numbers, there is a larger category of numbers called complex numbers. And a subcategory of complex numbers is something called imaginary numbers. You'll see this in the coming problems, but imaginary numbers happen whenever we're taking the square root of a negative value. So square root of a -1, we're going to deal with that, and we're going to represent that by using the variable I. I'm going to show you what I'm talking about. But before we do, it's important to understand that when we have problems that are in complex form, we typically write them in the form A plus BI. A plus BI, where we will have A be what we call the real part, and B what we call the imaginary part. Don't worry, we're going to get through all of this here together. But first, let's talk about where I actually comes from. And I have 3 different example problems. We're going to go through each one individually. So first, the square root of -25. If you stopped and tried to plug that into your calculator is going to have a fit with it. It does not know how to take the square root of negative numbers. And neither do we. We know how to take the square root of 25, but put the negative in front of it, and I'm kind of lost. That's kind of what happened to mathematicians as well. They would get to this point with the problem, and they'd have a square root of a negative number, and they wouldn't know how to deal with it because the math that they knew did not allow them to do this. So it's okay. Here's what we're going to do. We're going to split the part that we know and take out the part that we don't. Right? 25 times -1 is still -25, so I can split the square root of -25 into the square root of 25 times the square root of -1. Again, square root of 25 is something I can do. That's 5. And as we saw on the previous slide, anytime we have the square root of -1, we're going to just represent that by using the letter I. So the square root of -25 is 5i. Now, I know that doesn't mean a whole lot to us right now, but we will get to the application of this a little bit more later on. But for now, we need to be able to take a radical, like the square root of -72, and simplify it using the I variable where necessary. So I'll look at the square root of 72. I'm going to simplify this into the square root of 72 times the square root of -1, just like I did in the previous problem. And now I have to look at this square root of 72. And I'm going to simplify this the same way that I had done previously when we simplify a radical. I'm going to look for the biggest perfect square that goes into 72, which is 36. 36 times 2 is 72. And then I'm just going to keep that square root of -1 for now, set that to the side. The square root of 36 is something I can do. That's 6. And the square root of 2 is something I can't do. Now, to eliminate confusion with form, we're going to take that square root of -1 and we're just going to put it after the integer. So that's just a formatting thing. If you wrote 6 square root of 2 times I, it's not technically wrong. You just won't ever see it written that way. Let's do one more. -5 times the square root of -9. I'm hoping we get to a point where you can just take that square root of -9 and know that that's 3i. Now, if you need to break it down and still go through it that way, that's fine. You can, but I think we're going to get to a point where that's going to be pretty easy to do. And now the only math that I have to do is I have to read this. It's -5 times 3 times I. That multiplication sign there is implied. So I'm just going to take that -5 times 3 and get -15i as my final answer. So that's how we end up with I in our answers, but that's not the end of it. We can also do a whole bunch of math with these complex numbers. We can add, we can subtract, we can multiply, we divide. Let's focus first on adding and subtracting. And you know what? As a matter of fact, I bet you if you looked at these 3 problems that I have on here, I bet you could probably do these without any help at all. So I would encourage you right now, write down these 3 problems, pause the video, and then try them on your own. Remember, I is just a variable. Now, this variable means something, but we treat it exactly like a variable. So why don't you pause the video right now and give these 3 problems a try, and then we'll go over them momentarily. Go ahead. It's okay. I bet you can do it. Pause the video. All right, so the first thing we're going to do is we're going to, with this first problem, 8 minus I plus 5 plus 4i. We're going to treat the numbers together, and we're going to put the i's together. And we're just going to do the math. So we're going to do 8 plus 5, which is 13. Oh, let me change the color. I'll put that in red. 13. And then we're going to do negative I plus 4, which is positive 3i. That's it. That's all there is to it. Now let's go to the next one. 7 minus 6i minus 3 minus 6i. Now, folks, I would encourage you to do this. I would encourage you to take that negative sign and distribute it through to that parenthesis. Right? You want to take this negative and distribute it in to make it minus 3i plus 6i. That's going to make your life a lot easier. Because now when we go to put things together again, we'll have the negative 3 and the 7 will go together. And we'll have the minus 6i and the plus 6i go together. And my final answer in this problem is going to be, well, 7 minus 3 is 4. Negative 6i plus 6i, well, those cancel out. So my answer is simply 4. That's all there is to this one. Okay, the last one. 13 minus 2 plus 7i plus 5i. Don't let the formatting confuse you. We're still going to take that negative and we're going to distribute it in. So we'll have 13 minus 2i, or sorry, minus 2 minus 7i plus 5i. And we'll start putting things together. Like the 13 and the minus 2 go together, and the negative 7 and the 5i go together. That's nice that they're next to each other. That was an added bonus. 13 minus 2 is 11. And negative 7i plus 5i is negative 2i. Whoops, hold on. Let me get that right. Let me get that marker right. Negative 2i. It's my final answer. See? I bet you got those right. If you didn't, that's okay. Now's your opportunity to try. So I have 4 problems here. Why don't you pause the video right now and give these 4 problems a try, and then we'll go over it. Go ahead, pause the video. Okay, we'll go over these now. So the square root of negative 12. Again, I'm going to split this up. I'm going to split this up into the square root of 12 times the square root of negative 1. Square root of 12 is 4 times 3. I'll simplify it down. The square root of 4 is 2. The I comes next, and the square root of 3 hangs out at the last part. Good. Okay, what about this next one? Well, the 2 is just going to hang out in the problem. I'll split it up. I got the square root of 4 times the square root of negative 1. I got to figure out what the biggest perfect square that goes into 54 is. That is actually 9. 9 times 6 is 54. So we're just going to write that there. Now I'll do some math. I got 2 times the square root of 9 is 3. The square root of negative 1 comes out as an I. And the square root of 6 I can't do anything with. I'm almost done. I just got one more thing to do. I'm going to take this 2 times 3. I'll get 6i times the square root of 6. That's the final answer for this one. Okay, on to number 2. And this is just as easy as combining like terms. So in this problem, the 2 and the negative 5 will go together, and the negative I and the plus I will go together. What's my final answer? Well, 2 minus 5, which is negative 3. All right, next problem. Again, I would encourage you, drop the parentheses, distribute your negative. Don't forget to distribute that negative. And then look for the things that are alike. So 2i and negative 4i go together, and negative 3 and negative 5 go together. So my final answer, negative 8 minus 2i. Final answer. So that's what adding and subtracting complex numbers looks like. Let's see what multiplication looks like. Multiplication is going to be pretty much exactly like distributing when we had something like the distributive property. We're just going to take the number that's on the outside here and we're going to distribute into our parentheses. That's going to be exactly the same. So we'll take the 4i times the negative 6 and we'll get negative 24i. And then we'll take the 4i times the positive I and we'll get 4i squared. Remember, I times I would give me I squared. But this is where things are a little different. Remember, I is equal to the square root of negative 1. So that means that I squared is equal to the square root of negative 1 squared. And knowing what we know about the relationship between radicals and exponents, when I undo a square root by squaring it, I've been doing that in the last section, so the square root of negative 1 squared is just going to give me negative 1, which means this is where my problem is a little different. Anytime I see I squared, like I have in this problem right here, I'm going to replace it with the number negative 1. So this becomes negative 24i, and that's just a regular I, so I can't do anything with it, plus 4, that still stays the same, times negative 1. I changed the I squared to a negative 1, which means when I rewrite this problem, remember, I want to put the real part first, I get negative 4 minus 24i. That will be my final answer here. All right, let's do the second problem. This is a binomial times another binomial. So what am I going to do? I'm going to FOIL. Don't forget to FOIL. Firsts, and we'll do that math. So 9 times 4 is negative 36. Outsides, 9 times 7i, which is 63i. Insides, negative 2i times negative 4 is positive 8i. And finally, lasts, negative 2i negative 2i times 7i, which is negative 14i squared. All right, now, just like in the previous problems, we're going to take care of a couple things. We're going to clean this up. So we got negative 36. I'm going to keep writing, plus 63i, plus 8i, minus 14 times negative 1. So remember, I squared is equal to negative 1. I know I can add some things together. I can take that 63 plus 8, and 63 plus 8 is 71. So I got 36 plus 71i. Negative 14 times negative 1 becomes plus 14. So now there's just one more case of simplifying that I need to do. I need to take that negative 36 plus 14 and get my final answer of negative 22 plus 71i. That is my final answer for this problem. Okay, time for you to try a couple. So pause the video right now, and why don't you try these 3 problems? Hopefully that you'll be able to do these without any trouble. Just remember, I squared is equal to negative 1. So when that comes up, you still have more work to do. So pause the video, try these out. All right, here we go. Negative 3i times 10i. Let's do this first problem. So I'll do the negative 3 times 10. I'll get negative 30. I'll do I times I. I'll get I squared. I know that I squared is the same as negative 1. So my final answer here is positive 30. On to the next one. I times 8 minus I. I'm going to take that I and I'm going to distribute it into my parentheses. So I times 8 is 8i. I times negative I is minus I squared. Remember that I squared is negative 1. So I get minus negative 1, which will change my problem to 8 plus 8i. Right? Remember, these two signs will change, negate each other. And I'll just rearrange it for fun. All right, last one. Foiling. So I'll do the firsts. 3 times 8 is 15. I'll do the outsides. Minus 3i. I'll do the insides. Plus 5i. I'll do my lasts. Minus I squared. I'll rewrite this. 15 plus 2i. I put these two things together. Minus negative 1. Well, minus a negative 1 is the same as adding. So my final answer is going to be 16 plus 2i. Folks, I hope this made sense to you. Of course, we will practice this in class. I'll see you then. If you have any questions, let me know. Thanks for watching.